Assalamualaikum and hi, I am Malik Zikri and I will explain assignment question number 5, question number 1. This is assignment question number 5, depletion type MOSFETs or D-Mosfet. Question 1. Figure 1 shows a D-Mosfet self-bias circuit. We are required to determine VGSQ, IDQ, VDS, VD and VS in this equation. The value of IDSS and VP are given. This is the slide referred to solve the problem in this question. This is the calculation for this question. Firstly, we need to find ID to plot on the graph for the inclined straight line. Next, we need to find the value of ID to plot on the graph to find the curve of the graph. After finding the second ID using the second formula, we can plot on the graph and determine the graph curve. From the graph, we can determine the value of IDQ, which is equal to 2.4 milliamps, and VGSQ, which is 1.02 volts. The value of IDQ and VGSQ can be determined at the intersection point of the curve of the graph and the inclined straight line. After finding IDQ, we can find VD, VDS, and VS for this circuit. This is the simulation results using the multisim simulation software. The simulation results and the calculation results are different due to a few factors. First, in the simulation, the IDQ values might be different from the calculation results IDQ. And secondly, the circuit in this simulation might produce a slightly different parameters value from the calculation result. That's all from me. Thank you.
Assalamualaikum and hi. My name is Haida Shahida binti Harun. My student ID is B0819101997. So, I have choose question 2, which is D-Mosfet bias circuit. The question is, refer to the circuit in figure 2, determine the VGSQ, IDQ, VDS, VD, and VS. So here the calculation of the circuit. We have to find the VGSQ, IDQ, VDS, VS, and VD. First of all, we have to find the IDQ and VGSQ. To find ID, we have to use this formula, IDSS. We have 4 conditions, which is VGS less than 0, VGS equal to 0, and VGS more than 0. So we just put the VGS in the formula and we will get the ID. This is the graph, which is the x-axis is VGS and the y-axis is ID milliampere. So we just have to plot the graph by referring the table just now. So I have put it here, which is a negative 8 VGS is 0 in ID, and negative 4 in ID is 2, and 0 VGS ID is 8, and lastly 2 VGS is 12.5 in ID. Then we just have to draw the curve line here. After that, we have to find the load lines so we can get the IDQ and the VGSQ. To find the load line, we have to apply KVL in here, which is 0 volt minus with VGS minus with VS, which is IDRS, equal to minus 4. So we can make VGS as 4 minus bracket 0.39 k ohm multiplied by ID. We need 2 points. For first point, I take ID is equal to 0 milliampere. In this equation, when ID is equal to 0, so the VGS is equal to 4. And now, for the second point, I make VGS is equal to 0, and we will get the ID is equal to 0.3. After got the two condition of load line, we have to construct the line refer to the table. So I put it here, which is 4 VGS 0 ID and 0 VGS is 10.3 ID. Then draw the line. Take the intersection between the straight line and the curved line. So we got IDQ is equal to 9 milliampere and VGSQ is 0.5 volt. For the VDF, we have to apply the KVL from here to here to get the VDS, which is ID is equal to IDQ. ID is equal to 9 milliampere. 18 minus 2.2 K multiplied by ID minus VDS minus 0.39 K multiplied by 9 milliampere is equal to negative 4. And VDS, we get minus 1.31 volt. For the VS, we just have to multiply the, for the VS, we just have to use V equal to IR, which is 0.39 k ohm multiplied by 9 milliampere, and then we get the VS. And also same to VD, just use V equal to IR, which is 2.2 k ohm multiplied by 9 milliampere equal to 19.8 volt. This is the simulation. The simulation result and the calculation is different due to some condition, which is the IDQ value in the simulation might be different with the IDQ calculation. And the other one is the parameter in this circuit might be produce different value than the calculation. Then that's all for me. Thank you.
Here is question 3. Is to determine VGSQ, IDQ, VDS, VD, VG and VS. Given IDSS equal to 6 milliampere and VP equal to negative 3 volt. First of all, when VGS is negative, ID equal to 0 ampere, VGS equal to VP equal to negative 3 volt, and then VGS equal to VP over 2 equal to 1.5 volt, and the ID is equal to 1.5 milliampere. When VGS is positive, VGS equal to 1 volt and the ID equal to 10.67 milliampere. After that, we can find VG. VG formula is equal to R2 times VDD over R1 plus R2. We use the formula and get the answer is VG equal to 1.5 volt. Here is a graph. From the graph, we can get a Q point. And then plot the graph using value of ID at y-axis and value of VGS at x-axis. Then we can get the intersection of two lines, which is Q point. From the Q point, we get the value of VGSQ equal to negative 0.8 volt and IDQ equal to 3.1 milliampere. Here is simulation of D-Mosfet voltage divider circuit. As we can see, multimeter 1 is to measure voltage at RD and multimeter 2 is to measure voltage at RS, and multimeter 3 is measure voltage value of VGS. The measure value is quite different to the calculate value because of some errors. As we can see, at multimeter 2, measure value of Vs is 16.21 millivolt, and we can consider 0 as calculate value because millivolt is near to 0. That's all from me. Thank you everything.